All right, Matias, Cuba is my name, and Confluent. Before we start, we actually had a session with our CEO and everyone else saying we're not supposed to say Confluent, we're supposed to say Confluent. Anyhow, long story short. I walked around here the hall all day today and spotted that most of the booths and the vendors and everything else talk about data science, data analytics, business intelligence, and so forth. And what we're here to talk about is before you actually get there, how do you get the data readily available to those systems? And how has life changed for your data engineers in the organization? If you look at it the old-fashioned way, we started off, we sort of got this the way we should build. You build your application, you need a data store underneath, and you need a presentation layer, whether it's a mobile or a website or something else. We standardized on this approach many, many years ago. And we continued building from this particular model up till this point, and we still do. So we build a new application and a new data store and another application and a third data store and a fourth and so forth. And what happened eventually was that some people would just say, you know what, I'm also interested in your data, whatever you're producing, because I could use that within my application. From that arrived what we call messaging as sort of a fundamental technology. How do we connect your data stores with new applications, your data warehouses and everything else inside an organization? We started to build point-to-point connections using message queues, using ETLs, using message buses and so forth to try to connect our data with the different consumers and applications of that data. And we have been doing that for many, many years, basically. And it's been working okay, I guess. We've had sort of control. We added a layer of data warehousing if we want to have a long-term storage of data, where we can pretty much process data as we like. 10 years trends, anything like this. And if we actually have new systems and we want to pre-populate them with data, we can take data from our data warehouse and populate new systems, etc. The problem with this model is basically if you saw the first image and picture, it was a data lake. Messaging systems is pretty much like a fire hose. You store a message, you put the message into a messaging platform, you have a consumer on the other end. Once that is consumed, you throw away that message, basically. And you end up building an enormous amount of these point-to-point links to the actual fact where you almost lose control. Or we have customers that actually lost control. What applications are connected to what data? What happens if we pull the plug on this messaging queue? How many applications will stop working then? Who has documented this? Because we started building this and have done so for the last 15, 20 years in our organizations. So really, a messaging platform is sort of sipping from the fire hose in this case. The world has changed, which means that we now have to deal with things like Internet of Things. Well, I've talked to quite a few people that came by our booth already this morning. We have connected cars, you have utility companies, smart meters in electricity network, you have all your production manufacturing facilities, etc., producing loads and loads of data from millions or thousands of devices, depending on what size you are, and so forth. So we're producing more data than ever before. We take our old monolith applications, which were big, large code, and we break it up into microservices. So each and every microservices has either its own database or sharing databases in that case. What does that mean? It means that we have even more point-to-point connections from these new microservices down to the data store. So we're just basically enhancing the problem of message queues. Mobile doesn't help. We need access constantly from everywhere. We got machine learning and AI, what we just talked about. How good are they unless you can actually feed those systems with proper data? So we need to have a tool to be able to do this. And last but not least, we have the cloud. So we now try to store data in the cloud. We replicate data from the cloud into our data centers. And it's an ongoing synchronization of data between many, many, many more systems than we ever had to deal with in the past. So as we said, big data is many orders of magnitude. It's not longer a fire hose, it's a river of data that we need to deal with. And it's not an uncontrolled, flooded river we have to deal with. So the job for a data scientist has changed dramatically since then. For all of you working with data warehousing or data in general, you probably understand and see this image as this is sort of the way it looks like at my place. You have web applications and other applications either consuming data straight from a data warehouse, from a database, from Hadoop, or you're producing data and you push that into Hadoop, or you take data from two applications and you run that in an analytics engine and then you store it in Hadoop or somewhere else. And this spurs reality. Some of our customers call this the spaghetti sort of Western. We have one other large customer in this region that they call it the Death Star. So they have more than 5,000 different connections between consumers and producers. And whenever they pull the plug on one, they know sort of they're going to lose 6 or 7 services based on that, because it's not properly documented. And we kept building this. I see some of you laughing, because this is reality for most of us, right? Add to this and make it even worse. It's not just in one line of business that we do this. We have SaaS services, microservices, but we also have that across lines of businesses. And we add that into the cloud. I give you another example. An insurance company I've been working with, it's all built in silos. If I have a private insurance in that company and at the same time a corporate insurance paid for me, they can't tell. So I may be having a double insurance, I may be lacking one insurance, etc., because they cannot synchronize data from their system and get one unified holistic view of Matias and what sort of customer I am, what sort of package I need, etc. Because we built all of this, and you see all these connections and we say, I want access to this again, and I want access to that. And we're just making life worse for each other by adding new applications. Every new application says, I want access to this. You build this, you build a new data store, and it goes on and on and on and on, so to speak. So this is reality. It's what we call the pre-streaming world, basically. So what it means for a data engineer, actually, to provide data and all the knowledge and notion, everything we have and produce inside the company, to the company, for the benefit of that company, is that they need to actually control that stream or channel that data river. Not as an uncontrolled flood or river, but really as a controlled stream of events. They also need to be able to provide that in a format so that your tools and engines and everything else can actually accept, understand, and work and process that data. And last but not least, it has to be real time. Because the old days when you produce data, you store it somewhere, and then after a while, you read it out again and you process. Another application comes in, I also want to read that same very data, and third one, etc. It takes a lot of time, especially if you deal with old legacy systems like mainframes and so forth. We've had situations where customers that it takes up to 16 weeks to get an approval to actually read data out of a mainframe for transactions and everything else. What if you would have a system that can actually, as soon as a transaction happens inside a mainframe, it automatically gets produced and published into a new system, a streaming platform, so you can process that in real time. It allows for a complete different sort of mindset of how we build application. We call this event streaming platform, and I guess hands up a little bit, who's familiar with it like event-driven architecture and event-based? That's good. That's at least half or more of the population. So what is an event streaming platform? Well, an event streaming platform basically is something that you can take any source of data, whether it's your mainframe, your relational database, your NoSQL or SQL server, or whatever it may be, anything that produces data in your company, and publish that into the streaming platform so that you can either store this long-term inside your data warehouse, Hadoop, or anything else for purposes of, I don't know, backup or just later on get a trend and read out of this data. But even more important, you can actually read the data as it happens. When data gets produced, push that immediately to your analytic engines and all the other tools you have to process that data as it arrives, and so forth. That's really the promise of an event streaming platform. All your data, real time. Obviously, there are other elements into this. Security, for instance. If you now publish all data, put that in one place, so for everyone else to be able to subscribe to that data, there's a lot of responsibility for the ones there who, should everyone have access to this data?
Okay. Because today when you talk event-driven, you talk a lot about data-driven also in the same content.
Yeah.
But I mean, what's your point of view? I mean, usually you have some existing, like a warehouse, you have a lot of different data sources, and maybe you have some data you don't have yet, so maybe you want to ingest the raw tables into some lake or something. What's your point of view in this picture? Can you have different type of data sources coexist in event streaming platform? Or does everything have to be raw data?
Absolutely. I think it's a good question, and yes, there is a position still for a data warehouse. There is still a position for databases, but neither of them can ever process anything in real time. That's reality, basically. So you can use a streaming platform to feed the data warehouse. By simplifying the way you can produce data and put that in, you can actually feed your data warehouses more data, if you wish, and so forth. But to respond to your question, is merely, this is a platform you can actually use. I'll give you a few use cases at the end of this, but so you can see things that you could never ever do in traditional platform like a database, data warehouse, or anything else, that you actually essentially need a streaming platform, event streaming platform to do. But and as we said, the event-driven systems, the shift to this has already begun without even thinking about it. In the old days, when we occasionally call a friend or parents or brothers, sisters, or what have you, we now actually sit there and subscribe to them, publishing things to us instead. So we don't wait for them, or we don't call them and tell them how you're doing and all these sort of things. We sit there and wait, and they'll tell us. We just sit for this and wait to happen. Same goes with news, basically. Instead of waiting until next morning, something happened right now, we consume that news now. Instead of waiting until next morning, newspaper comes and we say, wow, look at what happened, and so forth. So the world has changed dramatically in event-driven organization like this already. So we are familiar with the concept of events as per se. This is a retail example. So what is an event? It can be anything. It can be that you sign up to a website, you search through certain articles in that website, and then you procure an item. Obviously that initiates a payment. Once that payment and you purchase this item, you may get an advertisement. And actually with an event-driven system, you may get a good advertisement, not for the same thing you actually bought 5 minutes ago, which is usually what happens nowadays, based on the knowledge you have. You may be able to actually produce something else. So if I bought a liter of milk, I get an advertisement or some recommendation saying, you know what, do you want some chocolate powder with that? Or boy, as we call it here in Sweden, for instance. Things that actually make sense based on my profile and what I actually did. All with an event-driven platform. So what does an event-driven platform do? Well, we talked about this. Publish simply and subscribe. So that's the sort of fundament of the whole thing. But the other piece of this is you can actually store data in a streaming platform. You can store that infinitely. We have customers that say, I want to store everything the last 10 years or even more. And others say that this particular data I want to store for just 7 days, enough for the data to get into my data warehouse and then throw away, or enough for me to analyze this data and then throw away. So that really is up to you and the data governance and the data modeling you have, how long you store each and every data set, or what we call topic in this case. And the last thing here as well, you should be able to process data as it happens, not process data after it happened, basically. Meaning put that in a database, and then read out, and then process, and so forth. So really, when it happens, and it makes a difference. And as I say, I'll walk you through one or two examples at the end as well. But this really is an event streaming platform, and the way it looks, and the way why storage becomes important is, it really is sort of a log in itself. So you start somewhere. Here's my first message or event, and here's the second, third, and fourth, and you just write down to the end of this like that, and you number them all. So I said this is 1, 2, 3, 4, 5, etc. in there. And then you, as a consumer, you can either choose to say, I want to have everything real time. As soon as something happens, give it to me from now on. Or I may be an application that I can't do that, but twice a day I can batch. So I read up till this hour, and then I remember exactly where I was. So 12 hours later, I read from this point the next 12 hours. Your call, basically. Or Fred, for instance, who's further behind here, it may be a brand new application or system, and in order to feed this system with enough data, I'll say, give me 2 years worth of data up till this point, and from now on real time. So it really is up to you how you process and handle this in a streaming platform. And the reason why you can do that is that because you decouple the producer from the consumer completely. So you basically produce as much data as you like. I am, as a producer, I don't even know who's going to read my data. That's not my job. I'm a producer of data, and I push that into the streaming platform. In our world, that streaming platform is called Apache Kafka. I guess you're all familiar with that, and so forth. I can walk you through that a little bit later as well. But then consumers can read this whenever they like. Oh, excuse me. Go back to that one just for... it's built distributed, so it really, really scales from day one. You can build upon this, and you can produce as much data as you like. You can have as many consumers as you like. You can scale this platform across multiple data centers into the cloud and back again, and so forth. So it really is an essential platform to run these things. And I mentioned Apache Kafka because that's where Confluent stems from. It all started at LinkedIn once. It started because they saw this sprawl of all the message queues and message buses and everything else, whereby they realized there has to be a better way. They scanned the market, realized couldn't find anything that had all these elements of processing, storing, as well as a message bus into it. So they built this, and LinkedIn allowed them to put this into an Apache foundation, so an open source model. Hence, the spread of Apache Kafka is enormous today, basically, and we see pretty much all digital native companies running this in one shape or form underneath their platform as an integration platform, whether it's Uber, Netflix, Slack, Salesforce, and so forth. But not only them, also your regular companies. So more than 60% of all the Fortune 100s is using Kafka in one shape or another right now as well. And to give you a few examples, we have LinkedIn, I already mentioned that as well. Netflix, they're processing 6 petabytes of data per day with a streaming platform. 6 petabytes of data per day. So whenever, I think it's 8 to 12 seconds, that's the sort of window. When you stop watching a movie or TV show, whatever, they have 8 to 12 seconds to come up with a good suggestion for you to watch something else. If they don't, you go talk to your wife or your kids, which they don't want. Uber. So whenever you have this map and everything, you can track and trace every car that is driving, where they are, when they're going to arrive, and all these sort of things. It's based on a streaming platform underneath. It's real time. Audi, great example, connected cars. They got about 850 different sensors in their new cars. Basically measuring everything. If one Audi comes here, and they basically publish all this into a Kafka stream. So say they drive down a hill and there's black eyes on the other side. If they can publish that information, so each and every car behind them realize they know this before they arrive, for instance. Or late at night after this event, you're going to come home, you live in the city center of Stockholm, you hate finding parking lots. Just add this into that and they will basically tell you, go left here, drive 2 blocks up, turn right, there's 2 free parking lots just 2 minutes away from your house. Imagine that sort of real-time situation, which you can never do with traditional data warehousing and databases. So there's concepts and ideas you need to think about here that potentially dramatically can change your business behind this. New York Times basically using Kafka to store every single article from the day they started, so that you can consume them either by paper or digital or whatever format you wish from that, and so forth. So most large financial sector organizations like American Express and a whole lot of others here in the Nordic as well is using Kafka as sort of a streaming platform to build their new applications on. So I'm going to wrap this up quickly as well. But look at this as like an event pipeline. You can take whatever data source you wish, publish that into an event streaming platform like Kafka, and then you can build use cases on top of that. What if in your retail you can actually in real time synchronize between inventory and whatever you sell, instead of doing that once per day or twice per day or whatever? What about fraud detection when your credit card right now is being used in Thailand and you're here? In the old world, you have to wait for that transaction to go through, you have to deal with the bank, and they'll eventually reward you afterward and you get your money back, but they lose money. What if they know that you were here and in real time say that transaction doesn't look good? We block it from ever happening in the first place. The bank would save a lot of money on that, as well as you and the problem. So loads and loads of potential issues. And just to highlight the difference between a contextual app, so everyone has a Google map or Apple map of whatever map and so forth. You can see where you are, basically. But the contextual piece around this is to actually see where are all the cars, when they're going to arrive, can they help me? It adds a different element, and you need a streaming platform to actually get to that stage. You can't really do that with a traditional database and states in there. So I'm not going to go through with this. There's a few elements that you can run in Kafka. The black one is open source. The blue one is community license. You're free to use. The orange one, if it really becomes business critical, or I have customer that says society critical, if you're government, there are other elements that you can replicate across data centers. You can do monitoring, visualization, and so forth, really making sure that your platform is up and running and not going down. This is really where Confluent comes to play. So I'm not going to go through that. Please visit us at the booth. We're a bit overdue. My name is Matias, Cuba. I'm in charge of Confluent in the Nordics, basically, and I'll be happy to talk more now or later. Okay.